So I'm gonna start with the session. Hello, everyone. Thank you for joining today's session. My name is Sakshi, and I am part of the Nullcon team. For those of you who are new, Nullcon Conference is a unique platform for security enthusiasts and professionals to showcase their research and technology to the community. We have our upcoming event, Nullcon Goa 2022, happening in September, and the focus of the conference is to showcase the next generation of offensive and defensive security technology. We are also happy to let you know that we have announced our Nullcon Security Trainings Goa edition, which will happen from 6th to 8th September. And to see all the different types of hands-on trainings that we are offering, you can visit our website. And coming to our today's speaker, we have with us Christian Folini, who is a Swiss security engineer and an open source enthusiast. He brings in 15 years of experience with mod security configuration in high security environments, DDoS, defense, and threat modeling. Christian is the author of the second edition of Mod Security Handbook and the best known teacher on the subject. He co-leads the OWASP ModSecurity core rule set project and serves as the program chair of the Swiss Cyberstorm conference. Christian is also a frequent speaker at conferences where he tries to use his background in the humanities to explain hardcore technical topics to audience of different backgrounds. So on behalf of all of us, I would like to welcome Christian. And before we go ahead, a few instructions for the audience. Our talk duration is about 30 minutes, and at the end, we will have a question answer session. You all can ask your questions using the chat option after the talk. I would request our speaker, Christian, to take charge of the session.
Thank you, Sakshi. Thank you for having me. Thank you for the invitation. And thank you for attending my session. So I'm going to introduce you to the OWASP ModSecurity core rule set in the next half hour. As Sakshi has already introduced me, I'm Christian Folini. I'm a Swiss security engineer. Originally, I was a historian, but then I moved over into IT security, and I specialized in web application firewalls, namely the open source ModSecurity OWASP CRS offering. So why a WAF at all? Why would you use a web application firewall at all? It's like using a seatbelt in a car. When you get into a car accident, then there is a good return on investment for wearing a safety belt. It doesn't mean that there will be no accidents, not at all. There might still be accidents, but if there is an accident, then you're better off when you wear a safety belt. Wearing a safety belt is a baseline safety measure. And when the bad thing happens, then you'll be less harmed. You're easier to get out of the car unharmed thanks to the safety belt. However, the safety belt is also only one of several safety precautions. Cars have become more and more safe during the last century. Perhaps there are airbags nowadays. You pay attention. You don't sleep behind the steering wheel, and so on. There are multiple defense measures, and the safety belt is one of them. You could call it as the first line of defense. In fact, the safety belt was one of the first inventions to make car driving more safe. And that is the same thing we face with a WAF. A WAF doesn't solve all your security problems. You still need to deploy safe code. You still need to patch your servers. You still have to pay attention to secure coding practices. But if you are attacked, then you're better off with a web application firewall. Doesn't mean it solves all of your problems, but usually it buys you time. It is more difficult for an attacker to exploit your website, your applications. Chances are an attacker will give up and move to the competition. They will leave you alone and attack somebody else. That is the promise of a web application firewall. Why do they move somewhere else? Because it's tiring, it's annoying. The WAF stands in their way. It disrupts their activities. It blocks their attacks. They have to think really hard how to get around the WAF. So WAF is useful in delaying attacks, not ruling them out completely. Good. A web application firewall is a big market. it is an interesting market in the sense that there are many, many commercial offerings, but only a single real open source offering. And that is basically ModSecurity, what people call ModSecurity. ModSecurity is an engine. It's originally an Apache module, so something you put into the Apache web server as a security enhancement. But that's only the engine. It is naked, so to say. How does the engine work? It is embedded in the web server. It has a rule orientation, so you configure the engine via rules that you need to define in a domain-specific language. We'll get to that afterwards. And it gives you granular control. So you always see your rules and you can deduce exactly what they're doing. There is no machine learning involved in here. And this is no cloud-enabled next generation, I'm going to ring home a super mastermind with artificial intelligence. No, not at all. This is honest, down-to-earth engineering. You write rules, and the rules are going to be executed by the engine. And if the engine thinks this is an attacking request, it's going to block it. It's as simple as that. The rule language is complicated. Writing rules can be annoying, but you always know exactly what's going on. And that helps. I mean, that is a traditional engineering approach, if you want. Good. So ModSecurity is this engine, and the engine is naked. Without rules, nothing happens. It's just the engine without configuration. So what you need to have is rules on top. And the rules on top that most people use is the OWASP ModSecurity core rule set. So engine underneath, rules on top. Rules you're getting from our open source project. If you have maybe 100 commercial WAF offerings on the market, I'm pretty confident that more than half of these commercial offerings also use the open source rule set. So when you go to Azure or Cloudflare these days, or any other cloud offering, they have a WAF service as well, and the WAF service is in part based on CRS. So you get ModSecurity core rule set on Azure or on Cloudflare, on AWS, Oracle Cloud, Akamai, Verizon Media now, Edgecast, maybe even Alibaba, but we're not quite sure with Alibaba, but all the other offerings, they have a CRS service in place that is often an add-on that you can enable. So they all reuse the open source tool. Why? Because it's basically without competition. There is no other open source rule set, and that means you have to do it yourself. You have to write the same rules, and they need to be better than the free offerings. So that is a lot of work. That's how most of the commercial users or the commercial integrators use our rule set for their commercial appliances, cloud WAFs, you name it. Good. So how does this CRS thing works? First, it works really well. This is research that a friend of mine performed in Switzerland a couple of years ago. On the left, you see a vulnerable application being attacked by Burp. And Burp would report back, look, at over 1,000 requests, I found a weakness in this vulnerable application. The application is made vulnerable on purpose. This is supposed to show you vulnerabilities. And then Burp would identify those and say, hey, look, I found, with over 1,000 requests, I found weaknesses. These are not 1,000 weaknesses, but the same weaknesses hit multiple times. And then in the second smaller column, you have a 5-minute installation of the core rule set. This is the advantage that bring you. It's over 80% of the requests that Burp used to report, hey, weaknesses found. Burp would now request, hey, anything, no problem. I don't see a security weakness. What is left of these requests that originally hit a weakness, and now this weakness is mitigated in over 80% of the cases. In fact, Burp is no longer able to push through with an SQL injection or a local file inclusion against CRS in this setting. there are additional columns called paranoia levels. Paranoia levels are a configure item in CRS where you adjust the paranoia, if you will, or the security level that you want. The higher the paranoia, the more crazy the rule set becomes, and the more aggressive it becomes. It will block faster, will say, hey, this is an attack, immediately fast, really paranoid in a sense. And of course, that brings false alarms. So this higher security appetite comes with a cost. That's why you're able to define this yourself. We're supporting 4 of these paranoia levels. So there is the first one with a minimal number of false positive. That is the default, gives you baseline protection. This is CRS for everybody. If you put up a website, we think you should do this always. When you have real data in the service, like real customer data, real assets, maybe an online shop, then paranoia level 2 could be your thing, where we hit more attack. We detect more attacks with this, but you might have to face a few false positives already. Online banking is meant to be on level 3, and level 4 is crazy, the strongest CRS that you can get. This is really like a mad dog that will bite the mailman when he's delivering something to your doorstep. So this brings a lot of false positive and means a lot of work for you to tune away the false positive. So it's like training a dog to treat the mailman as a friend. That is tuning away false positives. Thankfully, the dog responds well to training, but it's still a lot of work with an aggressive dog. That is the crazy paranoia level 4. Good. So we think this is pretty strong, and we think we're pretty good. How does that look for real? This is a graph taken from a blog post from a Finnish guy called Tuomo Makkonen. He published this, I think, 2 years ago, and he would look at various cloud WAF offerings. So Azure, Google Cloud Protect, Cloudflare, all those names that I've mentioned. And he would then attack these offerings with standard known attacking payloads. You see this in the rows. So vertical, different attack types, one after another, and horizontal from left to right, different cloud offerings. And now, as it happens, the green ones are based on CRS. We're not sure about Alibaba, though. So there are 2 green items with Alibaba. And then the red ones are not based on CRS. And you see generally that we do better than that. Interesting is Cloudflare on the right. Cloudflare basically uses CRS, but as you can see on the remote command execution line, Cloudflare is not doing very good. Azure is doing far better, if you will. That's probably because Cloudflare is not using all of our rules. So the integrators can make a decision what they're using, and they make their own selection. Like saying, we're afraid of this rule because it causes our customer false positives. We're disabling that rule, and that is a conscious decision. And that is okay, but it means that certain attacks will get through. And there you go. Let's move on. This impression from Thomas Makkonen is confirmed by recent research from a couple of Chinese researchers. They presented at Black Hat Asia this spring, and they presented their findings about SQL queries. They developed a new software in order to bypass Web Application Firewalls and their SQL injection protection. And their conclusion was, as reported in a Dark Reading article. Dark Reading is an online magazine. You see the URI in the bottom. So Dark Reading reported about this research, and the researchers have presented it at Black Hat Asia. And Dark Reading would say that the software was able to bypass the WAFs, the various WAFs. 3% of the payloads bypassed ModSecurity. So we block 97%. ModSecurity, that's us. That's when people talk about this, they always say ModSecurity, but they mean CRS on a ModSecurity base. So we blocked 97 of their attack attempts, while as Amazon AWS only blocks 37 of the requests, and Cloudflare in the same region, probably a bit higher than that. So CRS is way better than AWS. Apparently, as confirmed here again, and we see the same thing again and again. We have less bypass. It's harder to work around our rule set than work around the commercial competition, even around our integrators that are doing pretty good, but they disable certain rules for their business needs. Okay, next concept. We have this paranoia level where you adjust the aggressivity of the rule set, and we have the anomaly scoring. That is also a key feature of CRS. Anomaly scoring means an adjustable limit, and it separates the detection from the blocking. So you get an adjustable limit of how much anomaly or badness you would accept, and then you block. And that helps you when integrating a service or a system, because at first you're not sure if you trust this WAF. You're not sure if you're going to see a lot of false positive. So you deploy the detection, and the attackers and your legitimate users will score, and you tune away the false positive. And as you move forward, you reduce the limit and you get tighter and tighter. So more and more of the attacks will be blocked, and you start to trust the rule set because you see, hey, there are very few false positives. My customers are not complaining. I'm not getting any phone calls, no angry managers yelling at me. So we can reduce the anomaly limit further down. This gives you options in the deployment, and it's a tool when doing integration. It's by no means meant today, hey, we're driving in production with an anomaly score of 500. No. During the integration phase, we took this step by step. So it's not detection mode, blocking mode. It is iterative tuning, getting you more and more tight as you move along. Good. I have prepared a little demo now because we have the CRS Sandbox. CRS Sandbox is an online service that lets you try out ModSecurity CRS without installing it first. Say you're an enterprise and you have a penetration test or a bug bounty hunter, and they approach you saying, hey, look, you have a weakness. There is a vulnerability in your service. And you wonder, would CRS perhaps buy me time? We need to talk to the developers and need to fix this. This is going to take a lot of time. Could CRS protect this in the meantime? Could this mitigate the problem for us? And you can try this out now with the sandbox that we released last winter. How does this look? You have the link on top to the documentation of the sandbox, and we can then go to the website. This is the URI where this is explained, and I can then take the curl call, this is an example call, and I paste this here in my window. So I'm calling the website sandboxcoralz.org via curl, so the command line HTTP client. And then in the query string, I'm highlighting this now, I have a little attack. This is a local file inclusion attack that I'm simulating now, that I'm trying out. The sandbox doesn't fall for this attack. The sandbox doesn't have this weakness, but the sandbox runs CRS and will report back to me. So instead of blocking my request, what the WAF usually does, it will report back. Yeah, so there is a conceptual difference. It's not writing a log file now. It's reporting to the client, hey, look, I saw an attack in your request. If you would attack a service protected by CRS, the following rules would trigger in the backend and probably block your attack. What is trigger? We have 930.120. This is the rule ID. And then it says paranoia level 1. So this is a default rule. And it says we have an OS file access attempt. Oh, yes, of course. etc pass WD is a operating system file name. And on the second line, we have an additional rule, 932.160, again, a default rule saying, I saw a remote command execution because I found Unix shellcode. So the file name etc passwd is also a Unix shellcode. So two rules triggered an alert on this attempt, on this very poor exploitation attempt. We can improve that if you want, but this is now a simple example. The next two rules are administrative in nature, and the 949.110 simply reports we have a total anomaly score of 10. And that means the two rules, each of them added 5 points in an anomaly, and we score totally 10 now, meaning if the anomaly threshold that you can configure, moving quickly back, this is the stormtroopers doing limbo dancing. So if the threshold is at 10, the attacker has to score below 10 to pass underneath to succeed in limbo dancing. And if not, he will hit the anomaly threshold of 10, and the request would be blocked by a normal server. Not on the sandbox though, because the sandbox is here to report what it would do in a real installation. So now when we go HTML, just name it foo. If we go, let's do cross-site scripting attack. I have to do this in quotes. It will report back with a score of 15 now, with 3 different cross-site scripting rules triggering. That's very typical for CRS. In these highly popular attack categories like SQL injection, cross-site scripting, remote command execution, local file inclusion, we have several rules overlapping. So several rules are triggering. One is probably triggering on script, and the other one is triggering on alert. That's how you end up with high scores on these rules, on these requests immediately. So this is the sandbox. That means after the session, you can try out CRS immediately. And then on the website, you find additional documentation, how to get really going, how to install this, how to run it. Mind you, I said there was a 5-minute installation. That's as long as it takes to install this on an existing server, namely if it's Apache or Nginx. Good. Demo time. Problem false positives. I touched on this. So CRS is going to block attacks. And as it happens, it might also block a legitimate user. It depends on the situation. In worst case, a legitimate user has a very funny name with quotes in it, and then suddenly it starts to look like an SQL injection. That used to be the case. We've weeded that out mostly, but it's not out of question. If you move to a higher paranoia level, then more aggressive rules, you're going to meet or hit more false positive. Your customer going to be blocked at higher paranoia level. So you need to anticipate this. You need to fight these false positive. And you do this via so-called rule exclusions. On the right, you have a cheat sheet with 4 types of rule exclusion. This is how this works. You would say, I'm going to disable the following rule in this URI context, for example, or I'm going to disable the rule for this parameter. For example, the search form cannot trigger on all this stuff. For the search form, I'm disabling a lot of rules because I'm getting too many false positive. How does this work exactly? You can find tutorials at my website, netnia.com. And there we also host a rule exclusion software. There are free scripts that you can use to help you with these rule exclusions, helping you using the cheat sheet on the right. But there is also a commercial GUI that guides you to write this rule exclusion. That's a GUI that makes working with CRS easier. Or you're invited to attend one of my courses where I teach mod security and CRS in practice and how to run this in practice. Let me sum this up. CRS, or the OWASP ModSecurity core rule set, is meant as a first line of defense against web application attacks. It's by no means the only line of defense or your only security tool that you need. It is meant to be the first layer in multiple layers stacked behind each other. You need a holistic, a wholesome application security posture, and the WAF CRS is an important part of this. It's a generic set of deny rules for WAFs, generic in the sense that we have a lot of rules, and when a new attack hits, you're mostly covered. Even the log4j weaknesses we saw last winter, we were almost perfectly covered. There were a few evasions that we didn't cover by default. So the generic set was pretty good, but then we had to adopt slightly because we hadn't enabled certain things for a fear of false positive, and log4j, log4shell forced us to enable this as well. By default, we block 80% or a bit more of web application attacks by default with these generic rules, and you can raise the paranoia level to go into the 95+% region. And this is regularly proven again and again by people making the tests. And you have seen this in the Burp graphic first when Burp attacked a vulnerable application. ModSecurity and CRS gives you granular control over the behavior of the web application firewall down to the parameter level. So unlike an artificial intelligence system where you train kind of a black box and then you hope it works, you continue to have granular control. The problem with web application firewalls is often the training data. That has to be production training data. That is relatively dangerous training data. And what happens when you do a new release, new traffic, new types of requests? And if that causes false positive, then you have to retrain the whole engine. And that makes it really tricky. While as with ModSecurity and CRS, you have a tiny little screwdriver and it gives you granular control, and you adjust the behavior just in the points where the new release is now triggering false positives. So you get much better control, and it also demands a bit more knowledge, more experience on the side of the operator or the engineer deploying and integrating this tool. And this is where I can help you with my teaching, with a lot of publications I've done on the topic. I've written the ModSecurity Handbook, the 2nd edition, at least, and I've published over 180 pages about ModSecurity and CRS on my website, netnea.com, or come to me and join one of my on-site or online classes. Thank you for attention, and happy to have questions now.
Thank you, Christian, for this informative session. I am sure our participants must have found some important, knowledgeable inputs. So if anybody else has any questions, you can drop them in the chat box. Ali had asked that it looks great, but it would be nicer if we can see the false positive rates as well. Context, the WAF comparison between OWASP WAF and the commercial WAFs.
Okay. So I understand the questions. We now see the percentage of requests that are being blocked or false negatives bypassing the WAF. How many false positives do you get? I don't have the numbers, honestly. We're an open source project. We're not regularly seeing the traffic of our users. Certainly not the traffic. Certainly not the traffic of the online cloud offerings. So they would have to tell you, and they're not telling us. I'm sure the fact that they have disabled certain rules points to false positives. Now, when I work with my own customers on my own services, and I have enterprise customers with several millions of requests a day, so that's a decent size, I see them, honestly, I see them face false positives. It doesn't go away. but I see them having less and less false positives ever since we took over the project. So CRS is like 15 years old, and I came in as one of the leaders in 2015 or 16, and the false positive problem was really, really big. And we fought false positive hard, and we continue to do so. And by now we're in a situation where a new deployment, so an existing service, is getting CRS, and a default installation usually really continues to work. Also with a hard anomaly threshold, like blocking really fast as soon as it sees anything. When you go to higher paranoia level, that can go up to a situation where every request is blocked by default. And then you really have to tune away the false positive. But a default installation of paranoia level 1 is usually doing okay, and then you might have a few rough edges, but I cannot give you hard numbers.
Okay. Next question we have from Sahil. Can we set custom response if clients send any malicious payload?
Absolutely. You have complete freedom, the freedom that your web server gives. You can do anything. Give you 1 or 2 examples. So I can let it pass. I can block with a 403. I can redirect to a page. I can redirect to different pages, a complete freedom. I can also proxy to a special sandbox. So I can take the attacker on a special site, and he or she is not even aware that they're talking to the honeypot now. That is possible. Or I can simply drop the connection and no response sent out. You have complete freedom there.
Okay. How often are the rules updated? Is there some auto update? Are the rules based on CVE?
Yes, we actually do very few updates. We were planning to do a release this June, a major release, actually CRS 4, but we have to postpone because we got certain security information from the security researchers that found weaknesses in the rules that we need to fix first. So CRS 4 comes after the summer holidays, perhaps, and we release rarely, like let's say once a year, a major release because of the false positive problem. When you have a commercial or an enterprise level site, then you need to do a lot of testing. Deploying a new rule set means a lot of testing to be really sure, because the major new release is going to bring new rules, meaning a potential for new false positives. And if we would bring a new release every 2 months with new rules, hey guys, we have another 3 rules, they would do the same test campaign again. And that is really tiring and cumbersome for them. So what we do instead is we bring new rules only in the new major releases once a year. If you want the bleeding edge, then you can use one of the nightly builds, or you deploy our master or our main release line, our main development branch from GitHub. So for an open source project, you go to GitHub, you get the latest rules. But that might be a bit untested. There might be more additional false positive, not as well tuned away. But we generally don't do regular, often updates. So there is also no auto update function until you deploy it yourself. And it's not really CVE based in the sense that we're generic. We're not running after individual CVEs. Log4Shell forced us to do additional rules. So there was a particular weakness that forced us to do additional rules, but usually we're covered. Like 80–90% of CVEs, hey, we have this by default because we are generic. We have generic rules that block all the SQL injections, not only the latest CVE.
Okay.
Good.
If you have already answered this, you can pass it. How to manage this on an enterprise level?
So enterprise users often use a commercial integration. So there are over maybe 100 commercial WAF offerings. They pick one of those, or they deploy CRS on Nginx, Apache themselves with their skilled engineers. And then you need to manage your deployment process. That is important. You need to manage the rule exclusions on an enterprise level. So you have probably dozens or even hundreds of online services. You need to keep the rule exclusions in check globally, but also for individual services. And you need to do log file monitoring. So you need enterprise-grade log viewers and the tools. And this is where this CREX software comes in, where NEA, my company, provides you with a helping GUI that allows you to manage these false positives on a scale. Generally, I would say enterprise level works really nice, but it takes skills and it takes knowledge for your employees, for the system integrators, for system engineers, security engineers. In my experience, my 2 or 3 day courses are usually enough to get people rolling. So if you have a senior security engineer or application engineer, after 2 or 3 days of course, they're able to deploy this themselves. And then they often come back with 1 or 2 questions to me, but the rest is in the published material and in what they learn in my courses. It's not as hard. It looks a bit intimidating, but it's actually, you get the hang pretty quickly.
Okay, another comment is, been reading a few things about Karraza. Do you think that would be the future engine for the CRS?
Hey, Jabusor, good to see you again. Good to have you. Yes, Karraza could be the future mod security. Mod security, I haven't mentioned this, but the developers of mod security say they want to hand this over, the development, in 2024. It is a commercial company behind it, and they declared end of life for 2024. As far as they are concerned, somebody else has to take this over. We've asked them already, and they said they haven't made up their mind. Come back in 2024. And there is a new kid on the block, so to say, and this is Karraza, an alternative implementation that runs CRS. And I'm right now confident that Karraza can become a drop-in replacement for mod security. It is not right now. It can be used in production on Caddy and Traffic, cloud web servers. The Karraza developers are now working on an Nginx port, and eventually they also promise an Apache port. And if that all works out, in the end, you're getting a drop-in replacement for mod security. It's maybe 1 or 2 years away, but certainly by 2024.
Next question we have, can we set new rules based on vulnerabilities reported by DAST, if I'm pronouncing it correctly?
Yes, DAST is a newer technique. So these are new security ideas coming in. And yes, you can write your own rules, definitely in mod security. And CRS, the next major release, brings a plugin functionality. That means when you would write or generate new rules, you could integrate them easily into CRS. So you work next to CRS as an additional mod security rule set, or you integrate right into CRS and use the existing CRS functionality, like the scoring, for example. That works really nicely. Apparently, it takes a certain kind of knowledge to do so, but technically, it's not so, very difficult.
All right. Next, we have a comment through Naveen. Could you please walk through any rule, the payload specifically? I'm afraid we don't have the time, but yeah, I will just read it out. As a pen tester, I come under such scenarios where CRS is set, but curious to explore further on the rule in order to ensure all data is validated, or if it will allow me to bypass.
Yes, okay. We don't have the time to do this walkthrough here, apparently, but technically, CRS brings 200 rules that inspect the request. This is not an allow list. We're not checking whether the header, the connection header is conforming to the RFC. That would be an allow list. No, we do it the other way around. We say the parameter query smells like an SQL injection. So I'm going to deny it. This is how we do it. So not all the data is validated. All the data is inspected, and the headers are all inspected. And if they look suspicious, then they're flagged. But I couldn't guarantee a validation against an existing standard. That's not what we're doing. Why can't we do this? This is too much work because it depends on the application. I'm happy to do this. I do this for certain customers. I really welcome if customers want to do this, but it's usually a lot of work because you have to tailor the rule set for the application, and people shy away from that.
Okay, last two questions. There is a way to configure it as an anti-bot tool. In other words, in order to do some anti-automation protection.
Okay, that's a very good question. The simple answer is don't. Mod security is relatively poor in this regard, and CRS even poorer. And as we move along, CRS is more and more session agnostic. We look at an individual request. And anti-automation is apparently a multi-request, so this is session-based. And mod security has this functionality, but it's not very good. It's very limited. So there are better tools to do this. There are better commercial tools to do this, apparently. A content delivery network is in a far better position to do this. They have better functionality, they have better tooling, they have better insight, better sensors, better monitoring. So what CRS or mod security can do is very, very poor. There is going to be a plugin that will take IP reputation in consideration. Former releases have IP reputation rules that work via mod security sessions, but honestly, it's not very good. My go-to anti-automation tool on mod security, Apache, I'm a heavy Apache user, is mod QoS. So only mentioning that. QoS, mod QoS on Apache is a very strong, very simple anti-automation tool that works out of the box. So you don't have to go to content delivery network, but it's really the content delivery network that brings you anti-automation, I think.
All right. Last question. Rules in comparison to plugins. Can you elaborate?
Okay. Plugins are basically collections of rules. It is little groups of rules that we don't want to have in the main line anymore. So we move them out, or future functionality that we want to test as a plugin, or third-party functionality that somebody wants to integrate with CRS, but we're not likely to accept them into the mainline. Why? Because maybe they're exotic. Maybe they do very crazy stuff that we don't want to have. Maybe they're using mod security functionality that is too risky to have in our rule set. For example, plugins can call Lua code. So Lua is a programming language that runs on the server, and it's nicely integrated in modern web servers. But we don't want to do Lua in CRS. We want to be lean, we want to be thin, we want to be competitive, fast, performing, and Lua running code on the server takes away performance. So we say, if you want to do this, make it a plugin, and then people who want to have this functionality simply enable this plugin. And plugins are built in a way you just save the file in a folder and it's enabled. It's super simple. So plugins are rules with special functionality and more liberty in what they do, and that's how they become plugins. There is actually a plugin registry already on our GitHub. It's linked. It's a plugin registry, and we already have 15 plugins to begin with. You can use them with the older releases already, a bit more handwork involved, or they're going to be mainline with the next major release coming out this year.
All right, perfect. Thank you, Christian, once again. And that concludes our session. And thank you all for your participation in today's webinar session.
Thank you. Thank everybody. Thanks for having me. Bye.
Bye.